Okay, this is Dr. Kraus with a third random root locus problem. We've now got 2 zeros and 4 poles. Let's have a look at these. So our poles, -1, -2.5 are real, and then a -0.56 plus or minus 2.3j, and our zeros are at -3.5, -5. Oops, sorry about that. So, -1, -2.5, -3.5, -5 for my two real poles and my 2 real zeros, and then fairly underdamped. That's slightly not to scale. I should bring that in just a little bit. Slightly better. Okay, so I found my poles and my zeros, which is rule 1. I'm going to find the parts of my real axis that are to the left of an odd number of poles and zeros, which is rule 2. I know that n minus m is equal to 2, so my asymptote angles are going to be plus or minus 90. And then the one rule, or the one formula that I definitely allow my students to write down and not memorize, is that the point where the asymptotes intersect the real axis is the sum of the poles minus the sum of the zeros divided by n minus m. The imaginary parts are going to cancel when we add these together. So I'm going to get a -0.56. I guess. How much math can I do in my head? -1 minus 2.5, and then minus -3.5, -8, all divided by 2. So this is -3.5, -4.6-ish, minus a -8.5 divided by 2. So I guess this is going to be a positive 3.9 over 2 or 1.8. Okay, so my asymptotes are going to be over here somewhere. So it seems pretty likely. I could potentially double check my angle of departure here, but I'm pretty confident that I'm going to get something like that. So these two are going to leave and go off to the asymptote. These two are going to break out and break in per rule 5 combined with rule 1. If I start at my open loop poles, then these are two starts of a branch. Well, they can't just come together and stop in the middle of nowhere, so to speak. So they've got to break out. And then these are two ending points. And so it's not that this can go to there or this can go to there, because these are two ending points. So something has to come in and then go to these two ending points. So I've got to have a break out whenever I'm on the real axis in between two poles, and I've got to have a break in whenever I'm between two zeros, but the real axis is on my root locus. Or if I've got a point where when we did this in a previous example, the other option is if there's a 0 on my real axis and then it just goes off to infinity. Well, this 0 is a stopping point and infinity is a stopping point. So there's a break in there as well. So feeling pretty good about that as example 3. And if I come in here and generate it in Python, it looks like my sketch. And so I feel like I sketched it correctly. And my sketch then, hopefully this is obvious, but maybe not, serves as a verification that what I'm looking at, I must have typed everything correctly into Python to get a valid root locus that makes sense with my sketch. Thanks.